Hello, students. I'm Professor Benavides. Let's go over section 4.8 of chapter 4. Now, this is on decision structures and Boolean logic, and we're going to drill down on Python programming. So we first start off by reviewing the relational operators. We do this because we're going to be using these relational operators to create or to help us make decisions. So Python's relational operators are shown below, and they're the same as those used in the pseudocode earlier in the chapter. Something different, or may seem different to you, is that when you want to test for equality, we're going to be using two equal signs. And when we're going to test for something not being equal to, that's exclamation point equal sign. So when you use two of these together, there's no space in between these two characters. It's a common problem. So when we create our if statements to help us make decisions, we'll be forming Boolean expressions. And relational operators are many times used to help us create these Boolean expressions. So typically the Boolean expression that is tested by a Python if statement is formed with a relational operator. The general format of an if statement is if Boolean expression, colon, and then we put the statements in a block. So for simplicity, we'll refer to the first line as the if clause. The if clause begins with the word if, shall we say the keyword if, followed by a Boolean expression. A colon appears after the Boolean expression. As you all know, Boolean expressions are either going to be true or false. So beginning of the next line is a block of statements, sometimes referred to as a suite. All of these statements in a block must be consistently indented. When the if statement executes, the Boolean expression is tested. If true, the block is executed. If it's false, the entire block is skipped. So here's an example of some code. I'll be typing this in later on to make this come to life. But basically, you'll notice that we have 3 requests for data, test scores 1, 2, and 3. We put them into variables 1, 2, and 3. They're coming in as a float. We convert the string to a float so that the data is entered in as a real number. Then we calculate and display the average. And then finally, we make a decision. So we will congratulate if the average is over 95. So if average over 95, then we'll say congratulations, great average. So if you'll notice the test data that I have there, I enter in 100, a 96, and a 95. The average is 97.0. And of course, that is greater than 95. So we go ahead and say, congratulations, great average. The if-else statement. You use the if-else statement in Python to create a dual alternative decision structure. Some people call it a two-way branching construct. So the general format is if Boolean expression, then we have a block of code. Then we have the else clause, if you will, and then we have another block of code. So when this statement executes, the Boolean expression is tested. If it's true, the block of indented statements following the if clause is executed, and then the control of the program jumps to the statement following the if-else statement. If the Boolean expression is false, the block of indented statements following the else clause is executed, and then control of the program jumps to the statements that follow the if-else statement. A dual alternative decision structure will execute one group of statements if its Boolean expression is true, or another group of statements if its Boolean expression is false. Here's an example in using Python code. If I assign 80 to temp and then perform a test on line 3, if I say if temp less than 40, see that's a Boolean expression. Is it true or false? Is temp less than 40? If it is, I'll say a little col, isn't it? Else, regardless, nice weather we're having, you know, so that if it's 40, which is still pretty cold, guys, to 41, we're still going to end up saying nice weather we're having, you know, so the temperature is 80, which is, yes, I would probably say yes, it's very nice. So relational operators can be used to compare strings in Python. Here we have Mary being assigned to name 1, Mark being assigned to name 2, and then we perform a test for equality. So if name 1 is equal to name 2, notice if I were to just put 1 equal sign there, I would be assigning name 2 to name 1, and we don't want that in this case. We want to perform a test for equality. If that's true, then we'll say the names are the same. Else, we will print the names are not the same. So the 2 equal signs together is our test for equality. It's an operator that compares, in this case, name 1 and name 2 to determine whether they are equal. Because the strings Mary and Mark are not equal, the else clause will display the message the names are not the same. And as what happens in many programming languages, when you compare strings, every character is compared using the ASCII table. And so basically M has a number representing it on the ASCII table, A has a number represented on the ASCII table, R has a number represented on the ASCII table. So the big difference here is Y. If those, you know, so Y and K need to be tested, and they end up with different numbers, so they're not the same, and so we say the names are not the same. In this particular case, let's look at another example. We'll study the not operator. So the not operator is used to determine whether the value referenced in this particular case by month is not equal to October. So if I assign January to month, and if I say if month not equal to October, then I will print this is the wrong time for Oktoberfest, which is what ends up printing, all right? This example here, when you use relational operators to compare strings, they are compared character by character. Introducing the ORD function. Now this ORD function is not in your book. I just thought I'd go ahead and use it because you know, I think it's an interesting function. So instead of your program, I believe 4.4 uses an input function to import names. I just went ahead and assigned Mark and Mary to these variables, and I compared them. So if we'll notice there on line 6, if name 1 is greater than name 2, we will print Mary is greater than Mark, which is the case, and why. So let's find out why Mary is greater than Mark. So the Y in Mary has an ASCII equivalent of 121. The K in Mark has an ASCII equivalent of 107. So yes, Mary is greater than. So that allows us to make decisions. Like if name 1 is less than name 2, then I can go ahead and use that to make a simple sorting. I would print name 1 and then name 2. Else, we would then go ahead and print name 2 and name 1. Nested decision structures. You can put one of these control structures inside of another one. Later on, you'll learn that you can also use, you know, logical operators to combine them. But for right now, let's assign 35,000 to salary and 1 year to years. I believe your book used this as input statements, and I'm just simply making assignments. So we perform our first test on line 6. We say if salary is greater than or equal to 30,000, and then we have an embedded if structure here. We say if years is greater than or equal to 2. So in other words, in order to get this loan, you got to have a salary of 30,000, you know, or more, and you got to be in the job 2 years or more. In this particular case on line 2, if that's true, if it's true, then you would print you qualify for the loan. Else, you must be on your current job for less than for at least 2 years, because the internal if is what's not being satisfied here according to the data that we have. So if I put in 35,000, yes, it satisfied the first condition on line 6, but then we go to line 7 and we have to test for years. And is 1 greater than 2? The answer is no. So the else clause will fire. It will say you must have been on your current job for at least 2 years. That's what we'll print. And of course, in this particular case, the outer else doesn't fire because the person's salary was 35,000. Otherwise, the outer else clause on line 12 would fire. The case structure, guess what? Python doesn't have one, thank God. So kind of primitive, and it doesn't do everything that an else if structure can be used for. So the if then else if statement can be used in a similar way. Here we see an example on line 3. We are prompting for enter your test score, and then we go through a series of tests using the elif to prepare a output. So in this particular case, if I enter 59, if you go down this decision structure, 59, it catches on the first one there on 5. And so it should say your grade is F. So that brings us now to logical operators, so that, sometimes you can, instead of doing a whole bunch of embedded control structures, you can use these logical operators if it makes sense. We have and, or not. And so Python's logical operators work like the ones previously discussed in the chapter. Here's an example of an and, an or, and a not. So, oh, right. Well, see, this first code on here is correct. We have an and, right? And then let's see. Let's review them. We have and, or, not. Okay. We have the first one there. What happens is that you're testing for an acceptable range. Okay. So what happens if you look at this? If x is greater than or equal to 20, and x is less than or equal to 20, that's an acceptable range. Okay. If it's outside of that range, in this particular case, if x is less than or equal to 20, or x is greater than or equal to 20, then in that particular case, it will be outside of the acceptable range. And then we have a condition of the logical operator for not. Okay. So here's a test for and, or here's some code using the and logical operator. So we ask for salary, and we ask for a number of years on the job, and then this was very similar to what we did before, but we're using the and operator. You qualify for the loan, and else we'll say else you do not qualify for the loan, and there's the output down below. So that's an example of and. So Boolean variables can hold one of two possible values, either true or false, and they're many times referred to as flags. And when the flag variable is set to false, it indicates that a condition does not exist. When the flag is set to true, then it means that the condition exists. Here's a quick little example of using Boolean variables. On line 1, I set sales underscore quota underscore met. I set that to false. And then I go ahead and set quota to, what is that? 50,000, and sales to 55,000. So if sales is greater than or equal to quota, then I set the Boolean variable to true. Else I set it to false. So now I perform a test to see is the sales quota true. Then we'll print you have met your sales quota. And that is an example of using Boolean variables. So that's pretty much the end of this little presentation. I am going to go ahead and start Wing 101. And I want to go ahead and just type in a few little demos to bring this to life. Let me go ahead and close whatever I have on here, and we'll start from scratch. All right. So here's the, let me get to my place and time. So basically we went over the logical operators. We covered logical operators and relational operators so that we can help make decisions. So this chapter was all about, you know, making decisions, right? The chapter was called Decision Structures and Boolean Logic. So we started off with the if statement, and then we went to the two-way branching construct, and then we used a whole bunch of elifs, and then we covered the, you know, the idea of the Boolean variables, or we called them flags, and you know, we talked about how we can go ahead and use them in code. So I'm just going to go ahead and start a simple little demo program. I'm going to go File, New, and let's see what our first example will be here. The first one was that concerning the if statement, and we're going to go ahead and we could prompt for 3 scores, and then we can go ahead and then calculate the average, and then show the average, and then make a decision on here. But instead of prompting, I'm just going to go ahead and make assignments so that we can just go ahead and have less code on the screen. So for test 1, I'm going to go ahead and assign, like say for example, 100. And I'm going to go ahead and save this right away. I'm going to go ahead and just call this a demo. Call it demo. And I'm going to overwrite that. And I'm going to make my code window a little bit bigger by doing the Control+ sign so that you can see the screen. So I'm going to go ahead and assign test 2. This particular case, I'm going to assign 96. And then test 3. And just pretend that I did prompts, right? And then we'll assign 95 to that. So the next thing that we'll do is we'll calculate the average on here. So we'll say average gets, in this case, it would be test 1 plus test 2 plus test 3 divided by 3. Then we're going to go ahead and print out what the average is. So we'll say print, and we'll say the average is. Okay. So now that brings us to what to the part of the code where we're going to be making a decision, and we're going to say if average is greater than 95. All right. So then we'll say in this particular case, print, congratulations. Spell right? Congratulations, great average. Close the string, and let's go ahead and run this. So the average is 97.7, great average. Very good. I have too many spaces after here. Notice that there's, you may not be able to see it, but there's little dots there that help you see the number of spaces that you have. And so now that looks a little bit better. So this is a one-way test. There's no else clause. You know, so we performed a test to see if the average was greater than 95. So if the average was 95, well then nothing would, or even less. Let's say that test 1 was a 90. So in this particular case, the average is 93.66, and guess what? There's no printout on line 9. So the test on line 8 doesn't fire because it's not true. Average 93.66 is not greater. So the Boolean test was false. You know, Boolean greater than 95 was false. So that's this little demo. That's our first little demo, you know, using the if statement. Then we introduced the elif statement, which would be a dual alternative decision. And let's go ahead and just use the same little demo file to test this one out. So the first thing I'm going to do is I'm going to go ahead and make an assignment of temp to 80. And then I'm going to go ahead and say if temp is less than 40, then print, and we'll say a little cold. Isn't it? Okay, else, and here's the important part we need to remember here. I've got to press the backspace key here so that the else clause is not indented. Otherwise, it'll get confused. Then we'll say print, and we'll say nice weather. We're having. All right. Again, you can use single quotes or double quotes for your strings. Doesn't matter. Let me go ahead and run this. And it's nice weather we're having was the, you know, I guess I should use a period to use correct English. What do you think? Okay, I'll run that again. And a nice weather we're having in this particular case. So this is an example of the two-way branching construct, otherwise sometimes known as a dual alternative decision structure. So that brings us now to comparing strings. So let's go ahead and just erase this and do another little comparison. Here we're going to learn about the relational operators on here. So let's go ahead and put name 1. Let's assign name 1 to Mary, and name 2 to Mark. Then we'll perform a test and we'll say if name 1 is equal to, remember I put 2 of them on there. If I only put 1, I'm doing an assignment statement. That's what we want here. We want to test for equality. Name 2, put that colon in there. Just got to get used to it. Just one of those things you got to get used to. And then say print. The names are the same. Okay. Then here, instead of typing in the else this way, you've got to go ahead and backspace so that it can be lined up with the if. Okay. And then we'll say print. And to save space, I'll just say not the same. Forgive me on that, right? All right, so let's go ahead and run it. Not the same. Okay, of course, if it was the same, the names are the same. So every character here is compared on the ASCII table, right? And that's why they that Y and the K ended up being compared and decision being made on this particular case. Another example on here, using the not operator. So we'll say month is equal to, I'm just going to say January or Jan. How's that for? And then we'll say if month not equal to, remember that, and not equal to is this way, right? It's the exclamation point equal sign. That's a relational operator. October colon, in this particular case, we'll say print. I'll just say not Oktoberfest. Okay. Not time for Oktoberfest, right? And I'll make this be consistent. If I did put October, I guess I would need an else in this particular case. This else what? And I would say time for Oktoberfest. Okay. And a lot of advanced programmers, they love to do their logic and not. It takes a little bit of time to get used to that way of thinking, but it is common. Yes. Here's another example I want to go through that talks about how the strings are compared using the ASCII table. I'm going to introduce the ordinal function here. It's not in this chapter, but I do think it's important to understand what's going on here. So name 1 gets Mary, right? Name 2 gets, in this particular case, Mark. Then I'm going to go ahead and say if name 1 greater than name 2, colon. And then I'm going to go ahead and say print Mary is greater than Mark. Okay? Else, colon, and I'm just going to copy that and say Mark. Mary is not greater than, right? I could run it right now. And so Mary is greater than Mark. So what every character is compared. Of course, the difference here is the Y and the K. So let me go ahead and print out the proof. I want to show you the proof. The book does go over verbally what's going on here, but I want to go ahead and show the proof, right? We'll say the Y in Mary has an ASCII, American Standard Code for Information Interchange of, I'll put in the colon there, I think it makes it look nicer, ordinal of Y. You can put single quotes or double quotes, it doesn't matter, right? So the first parenthesis is for the function, ordinal function. The other one here closes the print function. And copy this, live life danger. You're either going to save time or you're going to mess everything up. So this one here, we're going to say the K in Mark has an ordinal, and then we're going to look for the K. And then I'm just going to go ahead and put in a print to make it look pretty. Give me a blank line. And then I'm going to go ahead and say print. Here are the names listed alphabetically. Okay. In this particular case, I'll say if name 1 is less than name 2. This is a simple sort. Who would want to do sorting this way? We have, you're going to find there's many different ways of doing this. Name 1, right? And then print name 2. Else, and then you could just go ahead and copy these two. And of course, that would be 2 and 1. And let's see what we got. So Mary is greater than Mark. The Y is represented by an ASCII of 121, and the K is represented by an ASCII of 107. Here are the names listed alphabetically. So you would have, you're using this to go ahead and can you imagine the trouble of, you would have to like do a whole bunch of embedding on this to get a whole bunch of names sorted. Later on, you're going to learn there's many ways of sorting, and we'll leave that for another day. So and now we're going to talk about the nested decision structures. Give you an example of that on here. So let me go ahead and get rid of all of this. And nested decision structures is just one control structure and another one. We're going to put an if and an if, but it could very well be later on. You're going to learn about repetition. So that would complete the 3 control structures, which would be selection, or sequence, selection, and iteration. So let's just set salary to 35,000. And let's set years to 1. And then we'll say if salary is greater than or equal to 30,000. And then what I'm going to do here is I'm going to embed. I'm going to embed. So when I press enter here, this is indented. Naturally, I'll say if years greater than or equal to 2. So it's got to satisfy 1, and then it must satisfy the next one on here. In this particular case, then I'll say print. You qualify for the loan. Okay. Else, notice how I'm aligning this else with the years thing, and it's really important here. You know, so it's not saving me a whole lot to do a copy, but I'll do that anyway. In this particular case, then we'll say you must have been on your current job for at least 2 years to qualify. Of course, that will fire based upon the internal condition. So then I press enter here, and then I'm going to go ahead and use the backspace to align the outer if with its else. They've got to be, you know, aligned properly. In this particular case, I'm going to go ahead and say print and say you must earn at least let's just say 30K. Make it, I'm getting tired of typing, right? And then print. Okay, well, I guess I should have set out the whole darn thing, you know. Per year to qualify. So let's go ahead and run that. You must have been on your current job for at least 2 years to qualify. Now, why did that fire? So line 4, if salary is greater than or equal to 35, the answer is true. So it dropped down to line 5. Otherwise, it would have dropped down to the else. Right? So let's go ahead and test that. Let's say, for example, let's say that I have a salary of, can you imagine, just 3,000, right? So let's go ahead and run that just to fire this. So now it says you must earn at least 30K per year, if I want to spell that right, to qualify. So on line 4, in this particular case, the Boolean condition of salary greater than or equal to 30,000 was false, right? So in that case, the else clause fired, and the lines 5 through 9 were skipped. Right? So let's come back up here and give the guy back his money, and let's run it again. And so after line 4 is executed, it's true, it drops down to line 5, and then that's tested. But guess what? He only has 1 year, right? So then if that's the case, you know, the else clause fires, and it says you must be in your current position for at least 2 years. So let's go ahead and test this with 2 and run it again. And now, of course, it says that you qualify for the loan. I believe the pseudocode in your book called for import statements. I'm just doing assignment statements to just get to the idea a little bit faster, or at least I thought I would. Now, there is no case structure in Python. If you're coming from another language like C++ or C or Java, you have the case structure. But you can use the if, then, else if statement in a similar way. Let's just go ahead and simulate that. So if I have a score, and set that to, let's set it to 59. You made that grade, right? So in this case, we'll say if score is less than 60. In that particular case, I'll say print. I'm just going to say F, right? And I know the book had a whole sentence and stuff like that, so I'm just going to go ahead and say F, right? So then we can continue going down the logic on here. I need to make sure this is flush left and say elif, short for else if, right? Else if score is less than 70, right? In which case we'll say print. In this particular case, it would be a D. Okay. Because now I could just go ahead and copy this, put that in here, again and again. So this would be 70, 80, 90, FDCB. Now let's just do one more. Or actually, this last one would be else. In this case, we get an A, right? All right, so let me go ahead and run that. And I've got a bad on here. Name error. It says SCOR is not defined. Of course it's not defined. I misspelled it. So we'll come right in here and fix that. Fix it with a 3, yeah, right? SC or yeah. So let's go ahead and run that again. Let's try this again. F. It's kind of hard to see it, but that's the output down here in the output. And of course, you can change that. I think you want to test each one of these. So let's go 69. I did 59, right? I did 59. Let me make sure I did that. 59 is an F, right? So let's do 69. That would be a D. 79 is a C. 89 is a B. And 99 is an A, right? So it prints A in your output window here. I know it's kind of hard to see, but that's what you see down here in the A. So this is an example of the elif, and we use this to test a sequence of things. Right? Logical operators, Python's logical operators are like the ones we discussed earlier. We have and, or, and not, and that's different than the relational operators on here. Let me see if I could do a little simple demo of this. All I need is x and y, so we can have x is equal to 20 and y is equal to 40. Okay. Then I can go ahead and say if x is greater than or equal to 20 and x is less than or equal to 40, what do I want to happen then? I want to go say print x is in the acceptable range. All right. Then let's just go ahead and run that, make sure everything is correct. So in this particular case, x is in the acceptable range. Now, then we have, we only needed x in this particular case. I guess we didn't need a y on here. So the next example on here would be testing for outside of a range. So we can say if, well, I could copy this and just make some modifications to it. I don't know why it's indented, but those selected and then tabbed. This particular case, I want to do an OR. And that tests for out of range. So in this particular case, we're going to say less than or greater than. And that's kind of like the opposite of the other one. It's like, you know, if something, like if you're saying enter in the numbers 1 through 4 for the menu item. Let's say you have the menu items for 1 to edit the employee, 2 to delete the employee, 3 to, you know, whatever. If they put in like a 5, then, you know, then you would say, you know, please enter, you would then say, please enter in numbers 1 through, you know, 5 or whatever numbers you gave them. We'll say is outside acceptable range, right? So we're only testing on X. We don't need the Y. Let me don't confuse you on this. So in this particular case, I'll run it. X is in the acceptable range. But what if I say 19 then? If I assign 19 to X and then run it. So 19 is outside of the acceptable range. What about 41? So 41 is outside of the acceptable range. Very good. Other example on here is if using the not operator. So we'll say if not, in this particular case, we're looking for temperature variables. I'll have to create a temp variable, or I could use X, you know. Yeah, let's use X greater than 100. In that particular case, then we'll say print and say this is below the maximum temperature. All right. So if I run it right now, it's 41. This is below the max temperature. You know. You know, the other one is catching also because, you know, 41 is outside of the range, and it's also not X greater than 100. I know the logic on line 9 might be hard for beginners, but basically the condition that needs to be, it's the opposite of whatever the Boolean is. So if you put 41 inside of X there on line 9, you say, is 41 greater than, you know, 100? The answer is no, but, you know, we're doing the not to it, you know, so in this particular case, then, you know, it's the opposite of it. So they would say this is below the max temperature. Continuing, let's go ahead and do an example of a compound expression on here. So let me go ahead and get rid of this. And I can go ahead and have salary in years. Example in your book uses the input function. I'm just going to go ahead and make assignment statements. So salary gets 35,000, and years on the job, or whatever you want to call it. In this particular case, I'm going to go ahead and just assign 5. So in this case, I'll get right down to the if statement, or the compound expression. So we'll say if salary is greater than or equal to 30,000 and years greater than or equal to 2, what do I want to do? I'm just going to go ahead and put here qualify. I guess I'll spell it all out. And now we have to backtrack a little bit, put in the else, make sure it's aligned with the if. And in this case, I'm going to copy and paste that. And then in this particular case, you do not qualify for the loan. Yeah, be nice, right? So you qualify for the loan because, you know, the condition on line 4 is true. It's an and. Both of those must be true, right? So in this case, if I drop this down to, you know, just to any number, right, on here, you know, or if I wanted to, I could just have years, say, years of 1, which was, and then run that. You do not qualify for the loan, would be the response down here below. Okay, so that's using an example of compound expression. The Boolean variables was the next topic on here, and so let's go ahead and type in this. Boolean variables used a lot by advanced programmers. They just love it. You know, so let's just go ahead and put it in. I'll maybe modifying the variable names a little bit, maybe shortening them a little bit. Quota met. I'll just go ahead and assign that to the value of false. And then I'll have the quota. I'm going to set that to 50,000. And the sales, I'm going to go ahead and set that to 55,000. Then I'll do my test. I'll say if sales is greater than or equal to quota, then what? Then I'll go ahead and then set the flag. So the quota met gets true. Notice how I'm typing in a capital T. Else, I got a backspace there and put in the else, the colon. In this particular case, then I will go ahead and then say the quota met is false. All right, then I'm going to go ahead and make another test here. I'll say if sales, or if, shall I say, if quota met is equal to true, then what? Then I'll print. And I know this may seem like it's a long way of doing things, but basically it is using, you're going to find out later on that the Boolean variables are very useful. This is just a little toy program to show you how to set a Boolean variable and use it. All right, so let's go ahead and run this. You have met your sales quota. So if we come over here and put sales, you know, of 49,000. Let me go ahead and run it. And in this particular case, there's no else clause on line 11, so there's no output. So if I wanted to, I guess I could put an else clause on here, and then you have not met your sales quota. That would be the you know, response that you give to create a two-way branching construct on line 13. So to repeat this here, line 1, we create our Boolean, we set it to false, and then we modify the state given a particular condition. In this particular condition that we're testing, is sales greater than or equal to quota? If that's the case, then I assign true to quota met. Else I assign false to quota met. And then finally, I make a test for equality here. Is what's inside of quota true? In that particular case, I say you have met your sales quota, or if it's false, then you have not met your sales quota. All right, well, that's the end of this chapter, you know, on decision structures and Boolean logic. We covered the, you know, single line if, the two-way branching construct if. We covered the else if. We covered how relational operators and logical operators and compound state expressions can be used to test conditions to make decisions. So these conditions are Boolean. Of course, this is named after George Boole, the British mathematician. So if the condition is true, you do one thing, and if the condition is false, many times you do something else. But other than that, I want to thank you for being with me, and I hope that you have a better understanding about making decisions using Python. Thank you very much.